In this video, we'll review the calculations needed to complete the data table for the 1.12 laboratory energy. So this is just a review. You've completed this simulation now. You've dropped one of these balls from each height of the simulator. You've indicated the mass of the ball here in the first column. You've indicated the time it took to travel 1 meter for each of these ramp heights. And again, you'll find that data table in the lab report itself on the second page. Here's an expanded view of the data table. I've provided the first two times that it took 1 kilogram ball, the yellow ball, to travel 1 meter at two different drop heights, 0.5 meter and 1 meter. From there, we can do the rest of the calculations. All right, so we'll look at potential energy first. This is the third column of the data table, and we need to use this formula. GPE, that's the gravitational potential energy, equals mass times gravity times height. Now, gravity is a constant, that's always 9.8. So that's the value we'll use to equal G in this formula. So we know that the mass of the yellow ball is 1, gravity is 9.8, and the height from this first drop is 0.5. When we do the calculations, we multiply 1 times 9.8 times 0.5, and we get 4.9, and we measure potential energy in joules, so we put J. Next, we'll calculate speed, and remember, speed is distance divided by time. So the distance was 1 meter. The time is 0.36. And if we do that calculation, it's 2.778 meters per second. And by the way, I would encourage you to use a calculator to do these different calculations and these formulas. Totally fine. All right, kinetic energy. The formula is KE equals 1/2 mass times velocity squared. So we're going to square the velocity first. And for our purposes, velocity is speed in this instance. So 2.778 times 2.778, that's how you calculate velocity. You take the number times itself. So we have velocity is 7.717. We'll put that into our formula. So we have 1/2 the mass, 1/2 times 1 times this velocity squared times 7.717, and we get our answer. Kinetic energy is 3.859 joules again. Okay, so the second example goes exactly the same way. Potential energy, mass times gravity times 1, because this time it's a 1 meter drop height, and we have found that that's 9.8 joules. Speed is distance divided by time. Distance this time is 1 meter divided by 0.24, and that equals 4.167 meters per second. Kinetic energy, let's do the velocity squared first. So that's 4.167, that was our velocity, remember, times itself, and that equals 17.364. Put that into our formula. Kinetic energy equals 1/2 times the mass, that's 1 in this case, times 17.364, and there you have the calculated answer of 8.682 joules. And you would continue that process through the rest of the data table to complete each column uh, completely for each drop height. All right, then to finish up, you'll just complete the data table and all calculations, make your observations on the conclusion page, complete that second simulation, take a snip, remember to include, um, complete the rubric, and submit both. Please let me know if you have any questions. I'm happy to help.